Let's learn about greatest common factors. Let's start off with some definitions. A prime number is a number that has only two factors. And those two factors would be 1 and the number itself. Let's list down some prime numbers here. 2, 3, 5, 7, 9, 11, 13, 17, 19, and the rest go on and on. So these are going to be all of our prime numbers, or some of our prime numbers. What's a composite number? Well, a composite number has 3 or more factors. So other than 1 and the number itself, there are other numbers that can be multiplied to get to a composite number. What about the number 1? 1 is not prime, 1 is not composite, because 1 has only one factor. That factor is 1. All right, let's look at the greatest common factor. What is the greatest common factor? Well, the greatest common factor is the largest number that is a factor of 2 or more numbers, and I want to just say terms instead of numbers. So it's found by finding the product of the common prime numbers. So our greatest common factor is really just the product of the common prime numbers. So let's look at the ladder method. The ladder method is going to help us figure out what the greatest common factor of these two monomials are. If we look at our list of prime numbers, we want to always start off with the lowest prime number, and the lowest prime number is 2. So we're going to go look at our 2 terms here and figure out, are these coefficients divisible by 2? Yes, they are. So let's put down the number 2, and then let's draw a half rectangle underneath. So when we factor out the number 2, it's the same thing, it's just dividing each term by 2. So 18 divided by 2 is 9. We still have the x to the third, y to the 10th. And then 36 divided by 2 is 18. And we still have the x to the second, y to the 8th. Now let's go back to 2. Are 9 and 18 both divisible by 2? No. So we can no longer use our 2. Let's look at the next prime number. The next prime is 3. Are 18 and 9 divisible by 3? Yes. So let's put a 3 outside of our 2 monomials and draw that half rectangle. So let's go ahead and divide our 9 and 18 by 3. 9 divided by 3 is 3. 18 divided by 3 is 6. All right, now we have 3 and 6 left as our coefficients. Well, I can go back and use number 3 because 3 and 6 are both divisible by 3. So let's put a 3 out here. I'm just going to highlight that to show that's one of our lowest prime numbers that will go into both 3 and 6. So 3 divided by 3 is 1, so I'm just going to lose my coefficient. So I have x to the third, y to the 10th. 6 divided by 3 is 2. We have 2 x squared y to the 8th. Now, we have factored out all of the prime numbers, so now we need to go and figure out how we're going to factor out variables. And it's a real easy trick. You look at common variables, for example, x and x. You can factor out the variable with the smallest exponent. So if we look at these two and we compare, we have x to the third power and x to the second power. So we can factor out x to the second because x to the second is common to x to the third and x to the second. So let's put our x squared here, and what I'm going to do at this point is just divide each one of these monomials by x to the second. X to the third divided by x to the second is just x. So we still have our y to the 10th. X squared over x squared is 2. X squared over x squared is 1, and 1 times 2 is 2, and we still have our y to the 8th. So now we're left with our y's, and what can we factor out? Well, you should see that the lowest exponent is 8. So y to the 8th is common to both y to the 10th and y to the 8th. So let's pull y to the 8th out, and then let's do our final division. We're still going to have our x. Y to the 10th divided by y to the 8th is just y to the 2nd power. And then our y to the 8th over y to the 8th is 1, and then we're left with 2. So I'm left with xy squared and 2. These are going to be called my leftovers. These are the terms that do not have any common prime factors. So, what is our greatest common factor? Well, the greatest common factor is the product of all of these prime common factors. So let's write down GCF is going to equal 2 times 3 times 3 times x squared times y to the 8th. Let's go ahead and do our multiplication. 2 times 3 is 6. 6 times 3 is 18. X and y are two different variables, so we can't do anything with the exponent except just rewrite them. So our greatest common factor is just the product of all of these prime factors. Let's try another one. Let's look at number 2. Again, it might be helpful to have our list of prime numbers right above. So I know that 2 goes into both 12 and 90 an even number of times. So let's start off with 2. Remember, we're always starting off with our lowest prime number that's a common factor. 12 divided by 2 is 6. 6a to the 6th, b to the 4th, c to the 5th. And then 90 divided by 2 is 45. Now, I can't use 2 anymore because 2 doesn't go into 45 an even number of times. So let's look at 3. I'm just going to highlight my 2. Let's look at 3. Well, is 6 divisible by 3? Yes, 6 is divisible by 3. 45 is also divisible by 3. So let's go ahead and factor out a 3. So we're going to take our 3, draw our half rectangle. 6 divided by 3 is 2. 2a to the 6th, b to the 4th, c to the 5th. 45 divided by 3 is 15. A to the 3rd, b squared, c. Now, 3 is not a common factor of 2 or 15, and neither are any of these other prime numbers that we have listed. So 2 and 15 are both going to be as factored out as they can be. So now we're going to go ahead and look at the variables. So both of these monomials have a's. So this one has 2a to the 6th, and the second one has 15a to the 3rd. So what we're going to do is take the variable and exponent that are the smallest. So that would be a to the 3rd. So let's factor out a to the 3rd. So a to the 3rd is common to both a to the 6th and a to the 3rd. So when we divide by a to the 3rd, we get 2a to the 3rd, b to the 4th, c to the 5th. And then 15, a to the 3rd over a to the 3rd is just going to be 1, b squared c. All right, now we've already factored out the a's. Now let's look at the b's. Well, b, the smallest exponent, is 2. So that's going to be one of my prime factors that I take out. So let's put out b squared and factor it out. So we're going to have 2a to the 3rd, b to the 4th over b squared is just going to be b squared, c to the 5th. 15, b squared over b squared is 1 times c. So now we've factored out the variable b squared. Finally, we have this c. There's a c that's common to both monomials. The smallest exponent is right here associated with that c. So that means we're going to factor out c to the first power. So we're going to end up getting 2a to the third b squared, c to the fourth, and then just 15. So these again here are our leftovers. Oops. Those are the prime terms that are left over that we can't find any common factors for. So let's calculate our GCF, our greatest common factor. We're going to do that by just multiplying all of our prime factors together. 2 times 3 times a cubed, b squared, c to the first. So let's just go ahead and multiply the 2 and the 3 to get 6, a to the third, b squared, c. So our greatest common factor would be 6a cubed, b squared times c. Okay, and let's look at this last example. This last example is not just two monomials, it's actually a polynomial. So this is how we're going to factor a polynomial. When we get ready to learn other factoring methods, you're always going to go back to greatest common factor in this type of factoring before you try to do anything that's slightly more tricky. So let's look at these numbers. We have 28, 7, and 35. Well, I can tell now that my lowest prime number that's divisible into all of these coefficients is going to be 7. So let's go ahead and draw a 7 here and then our half rectangle. 28 divided by 7 is 4. So you get 4a cubed b squared plus 7 divided by 7 is 1 minus 35 divided by 7, which is just going to be 5. Now we have 4, 1, and 5. Well, there are no other prime numbers that are common factors to 4, 1, and negative 5. So at this point, we need to factor out common variables. So we have an a to the third, a squared, and a squared. So let's factor out the a that has the smallest exponent. So that's going to be my a to the square, a to the second power. So let's go ahead and take a to the second power out by just dividing it with all of these terms. We're going to get 4ab squared because we had a to the third divided by a to the second. Here our a to the seconds will cancel and we'll be left with b squared minus our a to the squares cancel, 5b to the third c. Now let's look at our b's. Well, our smallest b variable, our smallest exponent associated with b is b squared. So let's factor out b squared because b squared is common to all three of these terms in the polynomial. So let's go ahead and do that. B squared. So we end up with 4a plus 1. It's important for you to remember that b squared over b squared is 1 minus 5b times c. Now, are there any variables that are common that we can pull out common factors? Well, no. We've factored this as much as it can go down. So let's look. These are going to be our leftovers. And let's go ahead and write down our GCF. Our GCF is going to be the product of all the prime common factors. 7 times a squared times b squared. 7a squared b squared is our GCF.